Hello everyone, in this unit we will start with chemical reaction and equation in which we will study what is chemical reaction, what is the difference between chemical and physical reactions, and how to balance a chemical reaction. What is stoichiometric coefficient and how do we use to balance these equations. So to start this chapter,
Hello everyone.
please
Today
stay
we will
with us.
start with class 10th chemistry chapter 1. Okay. So in this unit we will start with chemical reactions and equations. Okay. So the first term that is chemistry. Chemistry stands for chemical. Okay. The first thing is consider the following situation of daily life and think what happens when. पहला है जो that is the milk is left at room temperature during summers. Obviously the milk will get fermented. Secondly, an iron tawa pan nail is left exposed to humid air. All of you know that rusting of iron takes place. Grapes get fermented, food is cooked, food gets digested in our body, we respire. Okay, so in all these above situations, the nature and the identity of initial substance are somewhat means after some time, the nature or identity of the substance changes. We have already learned about physical and chemical change of matter in our previous classes. As we also know that physical change is the one, in which the we can which is reversible. That is, after the reaction, we can bring back that product into initial thing, that is reactant. Wherever the chemical change occurs, we can say a chemical reaction, or means or chemical reaction is where chemical change takes place. Okay, so what do you mean by chemical reaction actually? So in this chapter we are going to start with this: what is chemical reaction, what is chemical equation, how to balance chemical equation, and etc. things we will take place of. Okay, so in this unit we I welcome you for this. Okay, so we will start with activity 1.1. What is given in activity 1.1? Okay, first is clean a magnesium ribbon about 2 centimeter long by rubbing it with sandpaper. Hold it with pair of tongs. Burn it using a spirit lamp or burner and correct the ash so formed in a watch glass. As shown in figure 1, burn the magnesium ribbon. So what do you observe? You observe that ashes or the ribbon, magnesium ribbon, after it is burned, the ashes or the waste gets collected in a plate. Okay, so what is this place and what is it? So this is a chemical change because magnesium ribbon is converted into ashes. Chemical change takes place because these ashes or this ash or this waste cannot, that is, this waste or this ashes cannot be again converted into a magnesium ribbon. And since it cannot be converted into magnesium ribbon, that is, the reaction is irreversible, and hence the reaction or this reaction is known as a chemical reaction. Okay, now, okay, so what we have seen that magnesium ribbon also burns with a white flame and changes into white powder, that is ashes. So this powder is a magnesium oxide. Now the reaction is Mg plus O2 gives MgO, that is magnesium oxide. How to write balanced equation, how to write chemical formula, this might have studied in class 9 chemistry. Okay, now again, this activity 2.1.2 is take lead nitrate solution in test tube, add potassium. That is, here also chemical reaction takes place, and also so in activity 1.3 where zinc granules in a conical flask or test tube is taken, and in that flask only hydrochloric acid is taken or sulfuric acid. Since acid is taken in conical flask and zinc, so this displacement reactions might have taken place. Okay, so by these things what we can recognize is that observations that can be made is that chemical reaction takes place when there is change in state. Okay, change in state. Second is change in color. Evolution of gas takes place and change in temperature. Either one of the four things takes place, then the reaction can be termed as a chemical reaction. Okay, so those reactions are known as chemical reactions in which these one of the four um, characteristics or observation can be made. As we observe the changes around us, we can see there are a large variety of chemical reactions taking place around us. So a large number of chemical reactions take place around us. Okay, now we will continue this unit in next video. Thank you.
Okay, so the first topic is chemical equation. Okay, so in activity 1.1 where we bond the magnesium ribbon. So magnesium ribbon when bond was bond in presence of oxygen. So when magnesium and oxygen are magnesium bond in oxygen, hence the reaction takes place, that is magnesium reacted with oxygen and hence gave the magnesium oxide. Reaction magnesium oxide formula is MgO, because magnesium also has 2 electrons valence electron, whereas oxygen also has 2 electrons valence shell. Hence a chemical reaction has taken place where reactant magnesium and oxygen reacted together to give product magnesium oxide. Okay, the correct way of writing a chemical reaction is reactants are taken on left with positive sign or plus sign in between, so that which denotes that both. So in this, the substance that undergo chemical change in reactions are known as reactants, that is magnesium and oxygen here are reactants, whereas the new substance that is obtained is magnesium oxide and hence it is products. The word equation shows that reactants to product through an arrow is placed between them, which denotes that the reaction is taking place. And after the arrow, product is retained. That is, after the reaction, the obtained thing is product. That denotes that the reaction of that the completion of reactants has taken place and product is formed. Also
Okay, so here we will start with how to write a chemical equation. For example, the above equation only, Mg, that is magnesium, plus O2, that is oxygen. When they both reacted, they form one equation, combined form word equation, that is MgO. So there are two types or two forms of writing a chemical formula, either a word equation or a chemical reaction. Word equation means the formula or the name of that compound is taken as such, whereas in that chemical form or chemical equation, it is just the chemical sign, that is periodic table. The elements, short form out of those elements are taken. For example, Mg plus O2 gives MgO. If we count the number of atoms on each element, like Mg, total number of atoms in Mg is 1 here, and in RHS, that is on product side also, MgO has only 1 Mg, whereas O2, here in left hand side it is O2, that is 2 molecules of oxygen, whereas in product it is O, single O. That is, we have to balance this equation because number of atoms on left hand side is not equal to number of atoms on right hand side. देखिए, so means is not at particular, means they are not balanced actually. So our first thing is to balance, because we cannot write the equation unbalanced, because mass of elements is not is not same actually on both sides. Like single O has atomic mass of 16, whereas O2 has 32. So if we are going to calculate the atomic mass, that is magnesium has 23. Okay, whereas on both sides, whereas oxygen on one side, that is on product reactant side, it is 32, whereas on product, that is on right hand side, it is 16. So we have to balance this equation. So our next topic is how to balance a chemical equation. Okay, so first is to write of chemical formula, to write a chemical reaction in form of chemicals. Like here example that is given here is zinc plus sulfuric acid gives zinc sulfate and hydrogen. Do you remember the law of conservation of mass? Law of conservation of mass, that is, mass can neither be created nor destroyed in a chemical reaction. Okay, so since they are not neither created nor destroyed in a chemical reaction, hence total mass on that is present on left hand side or present on right hand side must be equal. So if while writing a chemical formula, if total atomic mass is not same on both sides, that is, do not follow this law, and this law has to be followed. Hence we have to balance the chemical equation. Okay, so example here is given of zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Okay, zinc sulfate plus hydrogen. The formula of zinc is Zn. H2SO4 is sulfuric acid forming ZnSO4 and hydrogen, that is H2. If we take here, we see as that here displacement reaction is going on. Like zinc being more strong acid takes up sulfate group from hydrogen, and displacement of reactions takes place. Now let's see here element see that box, element is zinc. Now number of atoms in reactant, that is left hand side, whereas number of atoms in product, that is RHS. In zinc there is one zinc on left, whereas one only in right side, so this is balanced. Hydrogen, if we see 2 and 2, so 2 and 2 both. Now sulfate SO4, either we can take sulfur and oxygen separately, or we can take it as singly, but that is same. SO4 also here in reactant also it is 1, whereas in product also it is 1 only. Okay, so or if we see separately, sulfur is 1, here also RH is also sulfur is 1, oxygen is 4, here also. That is, in this equation all the atoms are equal on both sides, on both sides of the arrow. Hence this equation is balanced, and hence we can say this reaction is balanced chemical equation. This chemical reaction is balanced. Okay, so after the main reason for balancing is that the total number of atoms of each element remains same before and after a chemical reaction, and hence follows law of conservation of mass. Or we can say it as mass can neither be created nor destroyed in a chemical reaction. So if there is change in mass on reactant and product, that is, mass is either destroyed or created, but in the universe total mass is constant, and hence we have to balance a chemical reaction. Now our next example is Fe plus H2O gives Fe3O4 plus H2. Now here see, Fe on left hand side it has only one Fe, whereas here it in right hand side it has 3 Fe, that is iron. Oxygen here is 4, 1, and on RHS it is 4. Hydrogen is 2. So the thing is, we have to balance this equation such that iron gets 3, oxygen here becomes 4, or maybe more than 4, but they should be balanced equally both sides, and oxygen and hydrogen is already 2, so we have to balance in such a way. Okay, how can we balance that? Can you guess anything? Okay, let me tell you. देखिए, Fe here on LHS it is 1. If we multiply it by 3, okay, then it can become 3 Fe. Okay, cap 3. Now O. Now if we go and now if we see for O, in left hand side it is only single O, whereas in RHS, that is right hand side, it is 4 O. So if we are going to multiply this 4 with H2O, valency of H2 on left hand side will change. Like it has to, if we multiply it with 4, it will become 8. So how to balance this? Now this is a problem. So if we multiply 4 also in RHS of hydrogen, then equations are balanced. Now we'll see it how is balanced. Okay, now here see, Fe plus H2O gives Fe. So the first step is to put a box around all the atoms, like Fe box, H2O box. So first step is put first draw boxes around each formula, and also do not change anything inside the formula. This is an important thing while balancing the equation. In the box we have to change nothing. Whatever we have to do, we have to do it outside the box. Now see, second, now we have to make tables. Writing element, 3 columns, 1 element. In middle we have to write number of atoms in left hand side, whereas number of atoms in RHS on third column. So number of atoms in reactants, I feel like, see, Fe has 1 on both sides. So 1, yes, second on RHS it is 3. So 3. Hydrogen has 2, and also right hand side it is 4, 2. Oxygen it is 4, 1 and 4 respectively. So first we have to choose an equation that contains maximum number of atoms. Okay, maximum differences in, you can see in oxygen, like 1 and 4. So the thing that is first we have to balance is first is oxygen. Now we have to make, step number 3 is to balance oxygen. How we will balance oxygen? We will again make table, atoms of oxygen. Okay, so maximum differences in oxygen. So we will balance firstly oxygen. Like first we will make 3 columns, atoms of oxygen in reactor and in product. The initial how much is, like 1 in reactor, and in product it is 4. So what we have to do in order to make that 1 into 4? So to balance we will multiply by 4 on reactant. If in case in product side it might be like different or less then we had multiplied with the number in product side. So multiplied by 1 into 4, up, what it became 4. Now it is balanced. So like see, outside the box in H2O on left hand side, because we have changed the valency on left. So see, 4 multiplied outside the box. Now this 4 has to be multiplied both with hydrogen as well as with oxygen. Okay, so now oxygen is balanced. Now step 4, you see, now we had what we have to balance. See what valency of hydrogen changed. On left hand side it became 4 into 2, 8, whereas it is on right hand side it is 2 only. So now to balance this, again we will make table for hydrogen atom. Initial we will write initial as 8, and in product it is 2. Now how can we make 2 as 4? Just by multiplying by 4. So in product side we will just multiply that with 4. So in product it is 4, 2 into 4, it also became 8, and in reactor it was 8. So now the equation we have nothing to change inside the box, whatever we have to do, we have to do outside the box. Like 4 is multiplied in front of oxygen H2O, and now in front of hydrogen also. Now you can see hydrogen is 8, hydrogen is 8 in both left hand side and right hand side. Oxygen is 4 and 4 on left hand side and right hand side. Now the only thing that is not balanced is iron. Now we have to balance this iron. Just by simply multiplying by 3 we can multiply, because there is no other group other than iron present in reactant. Okay, so we will just multiply it. Now see, okay, so here see, now iron is to be balanced. See, iron also initial it was 3, and on product side it is 1, it is initial, and 3 in product. So we will multiply towards reactant, multiplied by 3. So after every atom is balanced on both left hand side and right hand side, we will just write, we will just remove the box. That is step 6 is, we have to, first we will count number of atoms
that whatever we have balanced, is it correct or not, and then we will just remove the boxes. Now see, read this line: the number of atoms of elements on both sides of equation 1.9 are equal. The equation is now balanced. So this is known as hit and trial method. Hit and trial means we will put another numbers and we'll just balance this equation. Okay, now writing symbols of, now what is this seventh step is, almost the equation is balanced, but one important thing is to, after writing balanced equation, we also have to write the state or physical state of the compound, like Fe, iron. Normally we see iron in solid form only, so we have to denote that gas, liquid or solid by G, L and S. Means this has to be shown. The word equation is written if the reactant product present in solution. That is like H2O. It is present in gas form. So, Fe2O3 it's present in solid. So we have to mention the state of the compounds. And if something is present in solution, then AQ, that is aqueous, is written. That aqueous has to be taken in account. Now note that the symbol G is used with H2O to indicate that this is water in form of steam. Okay. Similarly, next equation is CO, that is carbon monoxide, is also gas, hence gas is resident behind that. Then equation CO H2 present as gas form, CH3OH liquid. So we have to just mention the physical state. Also in arrow we used to write reaction conditions, what are to be provided, like what the temperature needed, what is the reactant, anything else as catalyst. These all are taken into account. Okay. So this is the end of today's unit. Thank you so much. We'll continue this types of chemical reaction in next video. Thank you. अगर आपको वीडियो अच्छा लगा so please like, subscribe and comment. Thank you.